So our question number 21 is, it is asking a cylindrical conductor of length L and cross-sectional area A is connected to a DC source. Under the influence of electric field set off due to source, the free electrons begin to drift in the opposite direction of the electric field. Yes, it is true. So draw the curve showing the dependency of drift velocity on relaxation time. So basically, most of the students, what they are doing for first bit, simply we know drift velocity formula in magnitude small e capital E tau by m, and tau is our average relaxation time. So from this, if we will think Vd proportional to tau, directly proportional to tau, and if you will draw the graph like this, Vd versus tau graph is, it is asking. So the graph is linear in nature, then it is wrong. Okay, so you remember Vd proportional to, the Vd is directly proportional to relaxation time. It is possible when all other factors are constant. Yes, all other factors are constant. Yes. So in this case, so small e is constant, small m is constant, mass of electron, but capital E, that is not constant. Battery provides or maintains a constant potential difference. Okay, but from point to point your electric field varies. So basically this is your wrong concept. Vd is directly proportional to tau. So all of you remember drift velocity proportional to 1 by relaxation time. So relaxation time means what? Average time interval between two successive collision. So if the time interval will be less, then the speed will be more. Okay, so because of this reason, so the graph between drift velocity versus average relaxation time, okay, you can draw the graph inversely proportional. The graph is like this. Okay, this is the graph. And in second bit, it is given if the DC source is replaced by a source whose current changes its magnitude with time such that I is equal to I naught sine 2 pi ft, 2 pi frequency nu into t. So this is your whose equation? Alternating current equation, where nu is the frequency of variation of current. Then determine the average drift velocity. This is the best part. Determine the average drift velocity of the free electrons over one complete cycle. So first you see, don't go through the, okay, don't run after your answer. So what do you mean by average drift velocity over one complete cycle? Okay, for explanation I am explaining in a very simple way. Suppose this is your conductor. Okay, think like this, and the source is now connected. Instead of DC, it is connected with an AC source. This is your AC source. Let AC source variation is like this, I equal to I naught sine 2 pi ft. The variation is like this. Okay, we all know. Suppose this is your first half cycle, this is second half cycle. Let's think in first half cycle. Suppose in first half cycle, let us think this is the conductor. Let us think this is, suppose, the in AC source in first half cycle. Let's think this side is negative, this side is positive, suppose. Okay, and in second half cycle, in the same figure, what you will observe? In second half cycle, it will be like this. This part is your positive and this part will become negative. Okay, and this total is your what? One cycle. This total represents your one cycle. Okay, so when this is your lower potential and this is your higher potential, and in second half cycle this represents your higher potential, this is your lower potential. So in first half cycle, electron starts to move from lower potential to higher potential. We know always electron moves from lower to higher potential. Let the average velocity of electron is suppose 10 to the power 5 meter per second. Suppose in second half cycle, when electron starts to move from lower to higher potential, it will be minus 10 to the power 5 meter per second, because it is velocity. Okay, Vd vector. So drift velocity. So in one complete cycle, the average velocity will be Vd 10 to the power 5 plus minus 10 to the power 5. So in one complete cycle, we can think average drift velocity Vd is equal to 10 to the power 5 plus minus 10 to the 5 divided by 2, that is 0 meter per second. Okay, so this is the explanation. Yes, so what we have to write in second bit, we can mention like this: AC changes its direction after every half cycle. Okay, which implies in one complete cycle average drift velocity is 0. Though it is very simple to write 0, but it is too difficult to understand actually. Okay, it is not too difficult, it is very easy to understand. Okay, so you can understand like this. Okay, so I hope it is clear to all of you. In my opinion, it is a very good 2 marks question actually. In first bit, it is your confusing type question, drift velocity versus relaxation time. In second bit also, DC source is replaced by AC source. That question is also very tricky. Okay, I hope it is clear to all of you. Thank you.